everyone. My name is Sarah Deal, and I am joined today by my colleague, Ben. We are both data and analytics consultants at Thorogood and have drawn on our experience and expertise to bring you today's presentation on the future of data warehousing. So in today's webcast, we're going to focus on our take on where we see relational warehousing headed in the future. We will review where we have come from, where we are now, and also provide an unbiased and unvarnished perspective on where we see technology, data, and AI strategy going as it pertains to warehousing. And also what you can do today to future-proof your current architecture to get the most out of your investments. Before getting into the content of the webcast, I wanted to briefly explain who we are and our qualifications on this topic. So Thorogood is a specialist data and analytics consultancy with offices in the US, Brazil, UK, Singapore, and India. We offer a range of services within the analytics space, from strategies, tool selections, roadmaps, to trainings and adoption support initiatives, but the majority of our work is on application design and development. As a consultancy, we are customer focused, and we are also independent, meaning that we partner and work with several leading technology vendors in our space to deliver the best solutions to our customers. This independence makes us uniquely well-placed to discuss how we see technology evolving, particularly on our views on what the future holds for relational warehousing. We have long-standing partnerships with several of the leading technology vendors and work with a variety of other technologies, some of which I have listed on the screen here. All right, so now we will first get into the first section here and talk about the current landscape, where we are now, and the things that we see influencing data and AI strategy. I'll start with a brief history on the data warehouse and factors having a wider influence on the technology landscape over the past few years. The data warehouse in concept was actually introduced in the 80s, but fully developed in the early 2000s as a method of aggregating structured data from various sources to be compared and analyzed. The data warehouse really transformed the BI industry, enabled operational reporting, and began enabling advanced analytics to be performed. This also allowed for the actual execution of machine learning, data science, and artificial intelligence cases, which were previously more theoretical concepts, but we now have the capacity to perform. Although not too long ago, things were pretty different technologically at this point, a lot of things that are everyday items today were introduced in this time frame. Things like smartphones, social media platforms, online shopping, and targeted advertising, all huge contributors to the amount of data out there and really start gaining popularity in this time frame. With all sorts of new data sources and massive volumes accumulating, came a challenge in figuring the best way to store and process all of this to do more advanced data analysis. Shortly after this came clustering and parallel processing, resulting in the ability to scale. This really got started with Hadoop, but began to explode with the introduction of the cloud. And with the introduction of the cloud and the great push to move to it, data warehouses were made available as cloud versions. This brings added benefits, especially in lowering the cost, complexity, and time to value that have traditionally inhibited the adoption and successful use of data warehousing technology. As the volume of data and data formats generated are growing, we've seen a real increase in the use of cheaper approaches to store all sorts of data, more specifically data lakes and lakehouses, which we will get into in a little bit. And this leads us to almost today, where the most recent changes we see having a huge influence on the future, not only in how we store and work with our data, but on the wider industry as a whole, is the recent influx of consumer-generated AI like ChatGPT, Bard, and so on. As we become more technologically advanced, this directly increases the amount of data that is created and is out there. If you take a look here from 2010 to 2020, we have pretty drastically increased the amount of data that is created. What is crazy is looking at the future projections of data created each year and the drastic increase projected over the next 10 years or so. As I mentioned previously, we are quickly advancing technologically speaking, and as we move forward, we develop new capabilities, whether new technologies or modernizing and enhancing what we currently have. Over the past few years specifically, we've had to adapt to a digital everything world much quicker than we likely would have without a global pandemic and a shift to remote working. This alone drastically changed the way we live our lives and brought a newfound focus on technology. We're seeing a ton of investments and funding going into data and AI applications, and this is only projected to keep growing over the next few years. It's obviously going to be crucial for organizations to adapt to this in the future, and my colleague Ben will soon talk through how to future-proof your architecture and accommodate for changes in the technological landscape. Before we get into that and talking about how to future-proof your architecture, I'll share our views on where we are seeing recent shifts in the current landscape. We see a lot of people feeling like they have to decide between a data warehouse or a relational database or a data lake or data lakehouse to be able to use the particular characteristics that come along with each of them. Becoming more nuanced nowadays, and we are now seeing that there are features of each that support different use cases. As technologies are merging a lot of these capabilities together, it doesn't really matter if you're storing data in files or database if a lot of the features are going to be the same. To dig into this a bit further, you can see the different types of supported data structures here. Data warehouses allow for storage of structured data, which lakes and lakehouses do as well. The data lake and lakehouse have a bit more flexibility in allowing for storage of unstructured and semi-structured data as well. There are some nuances to querying as well, which you get low latency data querying and enterprise grade warehousing features from a data warehouse, whereas on a data lake, usually more advanced technical skills are required. Lakehouse provides similar enterprise grade querying and is evolving pretty quickly as well. Schema definition is something that will be required in a data warehouse, whereas it isn't needed in a data lake, but this can come at the risk of data quality. And a lakehouse can support both defined schemas and schemas on read. In terms of modeling data, data quality, data reliability, and privacy, the need for these will be fundamentally unchanged, but rather how it is done will differ between each given the different characteristics. Variability in each of these provides added value across each. Varying data structures provide optionality in data storage for different use cases. Different querying capability allows for user adoption and exploration, and different schema definitions provide trust in using information to make business decisions. And these are just a few of the values that are present with changes in the current landscape. Obviously, along with everything comes some challenges as well. So I wanted to share some of the challenges that we have been seeing when trying to achieve some of the values that I had just mentioned. The first is low latency reporting and querying. Right now, the technology to do live BI or real-time reporting via query interface on file-based data lakes is okay, and it's advancing quickly, but not quite there yet financially and performance-wise. In reality, there's still a lot to do. There's still a lot on-premise, so you might have a combination of on-prem databases, file shares, cloud databases, data lakes, lakehouses. It can become a bit complicated, and a lot of valuable data is still in legacy technologies. There's an investment that's needed to get everything on the cloud, and we are in a time where patterns are kind of quickly evolving. You might set out to build a data lake, but then a year later, you might need to be on a lakehouse. The level of innovation is great, but it prevents problems in trying to do massive multi-year programs for large organizations because the best practices and standards keep moving. This question then becomes how you take advantage of innovation in a way that works for today and also in the future. We're seeing organizations needing to invest in DevOps, CI/CD, code management technologies, and skill sets that match their architecture. And not all tools are fully accessible and operational in these DevOps setups. Data lakes and lakehouses have really exploded over the past few years. They can be complicated to understand and interact with without reasonable technical capabilities. We're seeing strong end user tools like querying evolving, but not enterprise ready yet, and there are a lot of options. There's a disconnect in business adoption and full value of modern systems because of the ability to interact with all personas. And the last thing here, technology can't be viewed as a golden ticket to solving all problems. We still need to be able to model data, validate data, capture metrics on data quality and effectiveness, and govern the usage of data. We're needing to do it in a diverse architecture with lots of technologies and patterns to keep track of. And like I said before, these are just some of the challenges that we see people coming up against currently. As we evolve and technology becomes more advanced, there will surely be new challenges that continue to arise and stand in the way, and it's important to anticipate and plan for that. On that note, I will now hand it over to my colleague Ben, who will talk us through what you can do to future-proof your architecture.
So Sarah took us through kind of where we are right now and kind of led in with the sorts of limitations we're hitting. We'll always have limitations and challenges. That's the nature of what we do. What I'd like to do is talk about what we're seeing organizations do to kind of work through some of these current limitations and also look forward given the rapid evolution of different technologies and different use cases. And of course, there's no kind of perfect solution or magic bullet, but we'll hope to help kind of get some thinking going and give a view of the things that we think are important. So I'll start out, not bringing it too theoretical, but talk about some of the key principles that we are advising customers to either take advantage of or to be considering when they're making decisions on tooling, decisions on patterns, and kind of across the board of how they're architecting their kind of full data systems, but particularly their warehousing. So optionality, and a pretty broad term, and some of the other points that I'll hit on after this sort of fall into this bucket, but wanted to lead with it. And really the point here is to avoid any lock into a single vendor or a highly proprietary tool set. We're seeing 3-4 years ago, and looking now, the tools are different. There's new players in the game that are now best in breed. So you want to have the ability to tap into the best technologies, the best patterns, and have really flexibility and adaptability in your system to kind of evolve over time. And I'll share a little bit about some of the techniques or places we think this can be done. Along the similar lines is openness to innovate and expect to change. And I feel like this one gets paid a lot of lip service. Every week or month or day almost, there's a new feature that's available in the software, or there's a big announcement of this new thing that's coming in a couple of months from software vendors, all these sorts of things. You can't use everything. You can't change every day. What we'd really advise is being able to do so, able to explore these functionalities, and maybe out of 10 features that are released as a new software package, maybe 1 or 2 of them really help satisfy some challenges that your business is facing or opportunities that you see. So it's not about every single new feature, using it, deploying it, standardizing it. There's time that goes into security reviews and coming up with how it actually works and deploying it and managing it then. But it's having basically the option to kind of avail yourself to new technologies as they become available, introduce new tools, but not necessarily doing it every instance. One kind of approach a lot of folks take, and I think one that's pretty logical, is like, we want to control what's happening. We don't want too much variability in our architecture. We don't want to manage a million different tools in a million different ways, and really you can't. One of the downsides to that is sort of overcorrecting and having a one size fits all approach to data warehousing. One set of technology, one set of pattern done in one very specific way, and naturally this can be kind of cause an overprescription, which naturally is pretty restrictive and rigid, and it can stymie innovation in a lot of cases. It can stymie the actual delivery of value. So you don't want to be so overprescriptive and say it's one thing and one thing only. But of course, it can't be a million and one options that people can choose from, and you have to then support the use of open source. And of course, open source has been around forever, but sometime we're seeing it more and more take on. And I'll talk about some of the places particularly it is. But we are really advocating a lot of places to look towards the open source formats, open source methodologies, programming language, those sorts of things to apply to really have an interoperable architecture. We are seeing kind of new tools that come out in the market, no matter how proprietary they are, able to work with these open source formats like Parquet or different languages that are fairly ubiquitous. I'd also think that the capabilities and evolution of the open source community is pretty impressive. Of course, there's caveats with that around what software you're pulling into your organization, but we're seeing a lot of evolution, a lot of talent in the industry being focused on these sorts of open source projects, and it's translating into the enterprise space and the private space. You'll obviously hear about multi-cloud in a number of years. You got to be multi-cloud. You got to be multi-cloud. I don't think it is you have to be multi-cloud. There's practicalities with cost, but also with having skills to understand and manage all these various platforms with their different nuances, evolve them over time, keep up with security, keep up with changes from those platforms. So it's not like you have to be multi-cloud, but you definitely want the kind of the option to tap into different cloud vendors. That might be for kind of technology reasons. There might be certain vendors that kind of are leading best in breed for certain parts of their component stack that you want to be able to tap into. The other thing it does give is sort of commercial leverage, that you might not have huge workloads on each kind of cloud system or lots of different software, but you have the ability to do so. So it really is about having the flexibility and adaptability to be able to do something, and then you can sort of pick and choose the right places to then kind of invest in different software patterns. And the other thing to say here is we don't see a need to pick a single technology, but we would want to apply technologies in a similar way. So if we're thinking about the patterns that we're applying, maybe the flows of data, even the standards that we're using in terms of naming conventions, we'd want that to be pretty consistent, but the exact technology that you pick doesn't have to be always the same. And the last one here, and I've seen a lot of this in the market, is investment in productivity enablers. So naturally, we all want to increase productivity, increase efficiency. It's kind of obvious to say. So how does that bolt on to your warehousing approaches? So I think DevOps is a huge one. So across CI/CD, code management, and automated testing, those things can be hugely valuable to operating faster, responding to the business demands more quickly, to removing any sort of issues or lessening the amount of issues that need to be triaged and handled. So a few principles to live by, again, pretty high level points. I'm going to go through each of these and again, try to give a little bit of detail as to what we think we can be doing to work towards these or some things to be aware of. So optionality first, and this one fairly kind of broad, like I said. A few things I'd be keeping in mind. One is around the kind of open formats that we're using. So storage-wise, you might be thinking about Parquet, which is highly compressed, tabular, and generally pretty accepted. And then on top of that, some of the metadata layers that we've seen gain a lot of popularity in the Lakehouse paradigm over the last couple of years, and you've seen them listed there. So these are kind of generally accepted. They're fairly ubiquitous. So like if we choose to store data in those formats, we're not going to run into an issue a couple years down the road, or we don't think we will, where that format doesn't work with the key software we want to use, or we have to go and rebuild a system. The same idea with languages and engines, and that's both on the longevity and portability of our code or frameworks that we're building, so be able to potentially be applied across different technologies or kind of outlast other sorts of things and live over time. But also thinking about your talent development, so building skills in things like Python, SQL, Scala, Spark, like those are like hugely important capabilities in the industry. It can help attract talent and maintain talent and be able to really take in like new innovative technologies, which we'll get to in a little bit. A few other points to make, thinking about like modularity of your solution. So the option to maybe swap out components. So, if we have a couple different database technologies at different organizations across the globe, like you can have like modular components of your solution that you could, push to Snowflake or Synapse or Redshift in different scenarios. And Sarah made this point. I think it's a lot of organizations are thinking it's in kind of an either or. It's okay, we can either go full relational database, or we can go full lakehouse, or we can full data lake, and not as some of them are saying that. Definitely like kind of keep the options open. You want to have some sort of conformity, some sort of pattern, but like understand what the virtues of those different technologies are and see how they're really honestly converging together to have a pretty similar kind of set of capabilities, and then the decision making almost becomes a little bit harder. Okay, I'm going to innovate. So a few things I keep in mind here is lock into proprietary, particularly formats of technology, but also like ETL tools. If you lock into something that's highly proprietary, it's hard to get data out of. It's hard for other things to connect to it. You're really kind of limiting your ability to like tap into other sort of software, or even in some cases tap into new features on that same platform, but generally not. Some things that we've seen be pretty helpful are trying to couple together innovation research or innovation investment, whether it's a POC or even more than a POC, alongside like big migration programs. So we're migrating from an on-premise data warehouse that's been serving the business for like 20 years. We can move that to a cloud modern platform on a lakehouse or whatever we want to do. And we're also going to invest in X, Y, and Z. So maybe new cataloging features, some more modern like data quality like software that's out there, and DevOps, whatever it is. So think about how you're kind of tacking on almost some of those innovative areas that you think can provide value to the business with like bigger migrations, which a lot of organizations are doing right now, is getting everything into the cloud, into these patterns. So one size fits all. And a lot of these points are somewhat kind of similar in nature. Obviously, they all fold together. So I mentioned this a little bit earlier, and there's probably not too much more to cover on it, but the idea that we do want kind of different options, and we don't want to feel we don't want our teams to feel like they have one pattern to choose, one exact technology to choose. It's not about that, but you don't want a massive proliferation. You don't want totally different approaches, totally different software in lots of different places. So there's always, like anything, a balance there. I tend to think the technologies can be a little bit different. A lot of the technologies are kind of keeping pace with one another. When you look across different cloud vendors, they've got a lot of the same technology, a lot of the same principles govern them, and they work in pretty similar ways. So you don't want like totally diverse sets of technology, but I think you can kind of grow the list of technology options and more put a little pressure on the patterns that are being used. So what are the different layers that exist in our organization, whether it's in S3 or ADLS, like that doesn't matter as much as having similar, raw curated output or whatever you're calling your different layers. So focus on the patterns and the standards as much as you can, and technology might be a little bit more open, and as long as those technologies are sort of the best in their class and supporting those different patterns. So kind of the points there is allow your patterns, your standards, and your principles to drive design. Don't let tool selection be the driving force. Of course, tool selection matters, and what the tools can do, and what your other strategies, they of course matter. And we're seeing a bit more around mesh principles. I think that'll only grow over time as there's ways to interconnect these different data storage entities. So the start of the data lake, the idea was get everything in one place in one single repository, and that became a bit of a bottleneck. So that's loosened a little bit, and we're now seeing, okay, now that we're a little bit more distributed, we're almost back to silos a little bit. We have to connect them together now with the cloud and with kind of modern bandwidth and all those sorts of things. We're able to connect those things. I'll go through these last few pretty quickly because a lot of the points have been hit. So use of open source. Look at this in file formats like Parquet, some of the metadata formats that we talked about, languages, data processing frameworks. So the ways that you can build skills in these things and also have it kind of scale both in terms of like time, but also to different softwares would be pretty effective. And we also see a lot of innovation in the space of open source, and it really pushes the idea of interoperability. To have a credible switching thread, and this one again is having the option to tap into software no matter really where it's being hosted. We see cloud vendors and cloud space leading the way. We don't want to lock into a single one, so you might choose different aspects of your platform to treat as a commodity. For example, data lake file storage is file storage no matter like which of the vendor options you're using. So kind of treat that as a commodity, treat that as interchangeable, and it really is. In the places where things need to be more proprietary, try to keep those things fairly generic. So if you do like want to switch workloads at different points in time, or you want to balance workloads for any given reason, depending on like internal skills, you're able to do so. And then some of the productivity enablers here, and a lot of these you've been hearing about, particularly Copilot capabilities are becoming the rage right now, and seeing as a way to enhance and elevate our ability to deliver software both in speed and quality. So thinking about how you can bring these things into your organization slowly and see what works, see what helps. So I'll wrap up with a few things here. Sarah made a few points, and a lot of what we're doing with data warehousing is the same that it's always been. We're modeling data in a way that takes business requirements or business logic, translated through data structures and ETL logic and data processing logic to like satisfy and answer business questions. So that's not any different, but we are doing it with basically different technologies. But the idea of facts and dimensions or type 1 or type 2 dimensions, that's not going to go anywhere. So one of the things we're thinking about is how we're skilling up people like business analysts, your key data users, to use these modern tools. So to get the maximum potential out of your lakehouse or your data lake or your MPP data warehouse, you want the folks that really understand the data to know how to use that. They might not be experts, but they need to know how to use it. Governance, so everybody can talk about governance, and it's becoming more and more complicated with the proliferation of data and the different technologies and patterns that are existing. So you've got to have some sort of strategy here, and there's a lot to cover. There's security, there's cataloging. We see cataloging and tagging becoming more and more important as these technologies mature. Data quality, again, for people to use data, it has to be right, it has to be correct, it has to be timely. So I think there are even some new challenges with things like more available schema evolution, higher velocity of data. So how are you tapping into and investing in the sorts of frameworks or capabilities to monitor and validate your data? A few others here. With new technology, you need to understand how to manage it from an infrastructure and security perspective, from a performance perspective. So how are you tuning your different storage and compute engines? Do you have a sensible cloud consumption procedure to audit, to deallocate, all that sort of thing? And then something that will always exist is that business connection. I think we're continuing to see self-serve and like bringing together the virtues of IT, data analytics, and business all together. So how are you having a good sense of prioritization? How are you aligning your business to what you can do technically? Okay, just to show a little bit graphically and really to get at the point of why does it matter for users and where do we think these things are fitting in. So we've got sources, file-based data lake, data warehouse. So raw data, there's a fairly low barrier entry in the data lake because you don't have to prescribe a schema. You're able to pull data in. And we're seeing organizations store all their full fidelity, full operational data in some sort of raw layer. We do have options through things like external tables to also surface this through a data warehouse. So I'll say a little bit more about this in a minute, actually. We're then seeing data transformed, and again, doing it very simply here, where you're modeling it, you're adding business logic, you're aligning it with master data, all those sorts of things, you're applying quality practices. We want this to be an interoperable format, and we really think of this as our lakehouse, where we might be using Delta Lake or Hudi or Iceberg on it. And then something's interesting, and I'll comment this in a second, is we're seeing a lot of organizations really duplicate then data into the data warehouse, copy it into, and I'll give some thoughts on that. And it's often a one-for-one copy. We are wanting to constrict the places that we are doing kind of processing. We don't want logic sitting in all these different layers. It'll become impossible to maintain, impossible to kind of migrate and evolve. From a user perspective, raw data is helpful for exploration. It is low barrier to entry, so you don't need to take the time to figure out how to load a table into a database. It's kind of one-click upload, and then you're able to analyze data through tools that are evolving. So there's value in having that data accessible for different use cases. We can see the value in your kind of basically your foundational data, whether it's supporting BI or data science. Kind of value of those interoperable formats of things being kind of ubiquitously available means we can use different tools to analyze them. So it's not locking us into a single sort of analysis tool, but it's ultimately giving us the option to have our data available across the organization. And then with databases, I think we're still seeing a ton of operational reporting. A lot of long-standing applications reliant on the relational database, and it's hard to see how that will change. There's a lot of logic held in there. There's a lot of investment. And I made the point, like organizations copying data from data lakehouse to database. We're hearing things like, well, people are just familiar with the database and how to query it. So how can we get our kind of lakehouse or data lake query engines to evolve so that that's not one of the kind of prerequisites or challenges with it? And how do we even see the lakehouse expanding across all our data to have it accessible in a similar sort of way? Running on time here, I'll just kind of wrap up with a few things on really what's next. So everybody's heard about generative AI and LLMs. So things to be thinking about: how can you store multimodal different forms of data? You're going to want unstructured data and semi-structured data available. And what is your cataloging strategy? Fast-moving data. So Sarah talked about low latency kind of data retrieval. Same with ingestion. We want the kind of the best of both worlds, and we see lakehouses, data lakes, data warehouses all kind of competing to be the best in the space to load data and get data out of it. Graph databases, so thinking about different sorts of storage. So when we're getting into NoSQL, how do we enable that within an organization, within hopefully a single central place? And I was thinking like vector databases becoming more and more important for LLMs. Something that's been interesting and with the explosion of AI is automated data management. So instead of us having to go in and figure out how to write an index or how to partition or when to refresh statistics, AI being able to do that. And again, a little ways off, but I wouldn't want to lose the concepts or the foundational knowledge of what good data modeling is, what good business understanding is, how that could be applied. But think how you might be able to use AI to improve your productivity. And serverless might be an answer for the second point. Serverless is really the concept of being able to tap into compute when you need it, and then it can deallocate itself. And I think this is really the ticket to getting access to data lake or file-based data. So if we can see that really compete with relational databases, exceed them, it'll be interesting. And it'll be interesting to see how databases might combat that. And then, like, who knows what else? There's a ton of innovation. Really, I think data warehousing maybe not getting as much kind of notice in the media or notice, but it is foundational to what we're doing. We are kind of storing and processing and making data available to make sense of it. An LLM is not going to make any sense of raw data until it's processed, it's named correctly, it's tagged. So just keep it in the forefront, even though it might not be getting as much kind of popularity, I would say, right now. And then I've hit on a lot of these points, so I'll close out pretty briefly here, but just a few kind of takeaways I want you to think about around maintaining optionality, avoiding that one-size-fits-all kind of stickiness. Focus on your governance, and it's easy to say that, but keep focusing on it. It's going to be an unlock for a lot of things. Think of it as an and, not an either or, but keep track of how things are evolving, and we might see something like the Lakehouse totally kind of take the lead on all these things. And then be thinking about your people development, your skills that you're building. Open source skills are very transferable. They are more and more available in the marketplace. So can you tailor your architecture to kind of align with people talent? So finally here, of course, we are a full service firm. We're working across a lot of these things, and hopefully, as you can tell, find it really interesting. It's a super interesting couple of years, really a couple of months in the industry to see how things are evolving, the investment, the changes, the new strategies, the challenges. So if there's topics you'd like to explore or even talk about, really interested to hear them and happy to give our view. So with that, thank you for taking some time with us today. Feel free to get in touch with Sarah and I if you have any questions or if you have any feedback. You can see the QR code here if you want to fill out feedback specifically for this event. We're happy to hear what you thought about it or anything you'd be interested to talk about. So thank you very much for your attention and your time today. Have a good rest of your day. Thank you.